Oh, hey there. I shrunk the screen, could you tell? All right, there's a reason I'm shrinking the screen is because I want to show you what happened over here with 2 and 1/4, which you've probably already talked about with your table for a while, so y'all probably figured it out. So what they did is they just decomposed 2 and 1/4 into um, some pieces. So 1 whole plus 8/8 is the same thing as 1 whole as well, and then they turned 1/4 into that automatic 2/8, right? So essentially what they did right there is they um, kind of decomposed ahead of time. That way they didn't have to turn it into an improper fraction using the formula. Instead, they only turned part of the number into an improper fraction. So they took 1 whole out and turned it into 8/8, and then added that to the 1/4 that was 2/8, right? And so basically, when you bring it back together, it looks like 1 and 8 plus 2 is 10/8. Now you have enough eighths to take away those 5/8, and you can turn that into the kindergarten problem 1 minus 1, and the fifth grade problem 10/8 minus 5/8. And just like before, 1 minus 1 is 0, and then 10 minus 8 is still 5/8. So our answer is 5/8, a weird looking 5, but that's what it is. So that's how they decomposed that. All right, so you can use that as well. If that made a bunch of sense to you, awesome, use it. All right, if you're like, that makes no sense, but I'm like super good at the turning things into improper fractions, cool, turn them into improper fractions. But you could also practice decomposing fractions, because like it's just another way to be flexible with the work that you're doing, so why not, right? So let's make the screen big again, because you have a couple of examples. I'm just going to run through them real quick. um, they both solved it correctly. They didn't really, I mean, they both wrote an expression. They didn't really solve it. They wrote an expression, which was what the question was asking. So they did a great job, both of them. Although Nancy answered it twice, I guess, because 2 and 1/4 minus 1/5 is an expression. They actually answered it 3 times. 2 and 1/4 minus 1/5 is an expression. Parentheses 1 plus 8/8 plus 2/8 close parentheses minus 1 and 5/8 is an expression, and 1 and 10/8 minus 1 and 5/8 is an expression. So, way to go, Nancy. That's like extra credit. Rebecca just answered it twice. All right. Anyway, there are 2 pots of boiling water in the kitchen. One has 3.5 cups of water. The other one has 1.5 cups of boiling water. Okay. What is the difference between the amounts of water in these pots? All right, go ahead and rubies it, and then come back. All right, so we read it once before. Let's read it again. There are 2 pots of boiling water in the kitchen. One has 3 and 1/3 cups of water, and the other has 1 and 1/2 cups of boiling water. What is the difference between the amounts of water in these pots? All right, so we're looking at, oops, we are looking at the wrong thing, because I did the wrong thing. Okay, so we got to underline the question. What is the difference between the amounts of water in these pots? All right, so 2 pots of boiling water in the kitchen. That's not an important number. One has 3 and 1/3 cup of water. Other has 1 and 1/2. So we're looking at 3 and 1/3 minus 1 and 1/2 if we're looking for the difference, right? So identifying our key concept, that's subtraction of mixed numbers. Now, can you turn this one into a kindergarten problem and a fifth grade problem? Talk to your tables. Why or why not? I hope that we're pausing and stuff. I don't know what's going on. Woo! All right, so welcome back. And yeah, no, we can't turn it into a fifth grade problem and a kindergarten problem, because, well, 1/3 is smaller than 1/2, so we can't take away 1/2 from 1/3. So let's solve this in 2 different ways. Let's try and do it flexibly, and then let's also just do it the way where we turn the mixed number into improper fractions. So go ahead and solve it. Try it both ways. Try and solve it by turning it into improper fractions, and then try and solve it in a flexible way, changing 3 and 1/3 into some more pieces, if you will, just like we did the time before. All right, come back and we'll see what's going on.